just to refresh your memory of where we're at, okay? This whole unit deals with how to analyze data by looking at numbers and by looking at graphs and looking at tables. We're analyzing two types of data: categorical data, which we did early on with those two-way tables, and we answered questions from there. That was how we analyzed it. And then we were also able to show categorical data graphically by using bar graphs or a segmented bar graph or a side-by-side bar graph. Then we moved on to quantitative data and how to analyze that. And we talked about the four main components: measuring shape by looking at graphs of quantitative data. And remember, the graphs of quantitative data are dot plots, stem plots, and histograms, okay? And then we looked at measures of center, like mean and median. We looked at measures of variability, like standard deviation and interquartile range. And now we're looking at the final component of analyzing quantitative data, and that's outliers, because we can actually, from data, numerical data, we can calculate whether values are outliers or not, rather than just look at a graph and say, well, it seems to be an outlier. Okay, there is a way to actually calculate whether something is an outlier or not. This we'll talk about if we have time later in the discussion towards the end of this lesson, but it's a good example of how outliers can affect the mean and make things look some way when they maybe really don't look that way. And that goes back to like the first thing we did, where we were using graphs to sort of to show misleading data, or how we can show misleading data with graphs. So one of the big things that happened in the States when Trump was president, one of the big things he did was he got through a bill that gave, the largest tax reform bill in decades. And his argument is that, and it turned out, I don't think it's here, but it turned out the average tax cut for Americans was $1,260. So he's saying, that's great. Everybody got a tax cut, because we eliminated tax breaks and loopholes. We're focusing on the middle class because everybody gets an average. The average tax cut was $1,200, which is a significant amount. But then the Democrats on the other side were saying, well, wait a minute. These tax cuts really only benefit. Yes, there were some tax cuts for middle class people and lower income people, but they really benefited the high income earners, what they call like the top 1%. And that's the reason why the tax bill went through, was to benefit them, because the Republican Party is sort of beholden to very wealthy people and corporations. Okay, so there was an argument both ways. So they took the data basically, and they said one thing, and then they said another thing, arguing against it. But we'll return to that later. Okay. In the last lesson, we talked about the 5-number summary. And when I say 5-number summary, it means these ones. Okay? And we were able to find these using our graphing calculator. We could actually find more information. There are actually more pieces of information, the 5-number. Like the 5-number deals with the minimum first quartile, median, third quartile, and maximum. Okay, we can use all that information to describe distributions. We can also use the mean and standard deviation and possibly even the range. So a lot of times when you get a graph of something, of some distribution, okay, you'll also be given a numerical summary, and it'll include the 5-number summary, all these values, and it'll also include the mean and standard deviation, which will help you describe the distribution. You don't have to calculate all of it. It'll be given to you, okay? But we're going to use this. This is the example we've been working on for a while, the salaries of 12 employees at a company, and we figured all this out in the last lesson, okay? And so what we can do is we can use some of these numbers to calculate whether certain values are outliers or not. Just looking at all these numbers, which values might be outliers? 185, because it's a lot bigger than the rest of them. The rest of them are sort of grouped around 34, 35, a few lower, a few higher. Maybe 67, because that's a little higher too. Sort of like we can kind of group all these together, and then these kind of stick out. There doesn't seem to be any value that's any outlier that's low. Okay, so what we want to see is, okay, what values actually are outliers? So outliers, like we talked about before, are unusually high or low data values. And here's how we do it. We need Q3, Q1, and the IQR to do it. We calculated those last time. They're given here. So we're going to use Q1, which is 34, Q3, which was the average of 39, and 43, which is 41. And remember, do you remember how to find the IQR? We did a subtraction. We did whatever the value of Q3 was minus Q1. That represents the middle 50%. So the IQR in this example would be Q3 41 minus Q1 34 is equal to 7. So to find outliers, we're going to find an upper limit of the data and a lower limit. Any of those values in here that are above or below that are outliers. So the upper limit would be Q3 41 plus 1.5 times the IQR, so 1.5 times 7. That gives us 41 plus 10.5, which gives us 51.5. That means anything above that upper limit in the data values is an outlier. How many outliers are there in the upper limit? There's 2. These are above. So these are outliers. We thought that there would be no lower outliers, but let's just double check that. So the lower limit would be Q1 34 minus 1.5 times 7, which gives us 34 minus 10.5, which gives us 23.5. Any values below that? So there's no lower outliers. So we would say 67,000, that's salary, and 185,000 are outliers. So that's how we calculate that. How can we show outliers and even distributions? There's another graph we can do. And this graph involves the 5-number summary and the outliers. And it's called a box plot. So the box plot is a graphical representation of the 5-number summary, and it also shows the outliers. So this is not the previous example. This is just a general box plot, okay? But here's how you identify everything. And I'll use red. Q1 is going to be the first, the left-hand side of the rectangle of the box plot. So this value here is going to be Q1. And if we go down to the graph, we see in this case it would be 6.5. Q3 is the part of the rectangle to the furthest right. I know we looked at that and we see it's a little under 10, close to 10. The bar that's inside the rectangle will be the median. The lowest value you see will be the minimum. So this is actually the minimum. The highest value you see will be the maximum. So this is the maximum. I'll just do this too. So that's how you would identify the 5 numbers. Then the outliers would be represented by the dots that are outside. They actually, another name for this is called the box and whisker plot, because they call this the box, they call this the whiskers, and anything outside the whiskers is an outlier. So these two, not only would this one be the minimum, it would be one of the outliers, with the other dot being the other one. Okay. And just like we did with other graphs that we saw relating to quantitative data, we can talk about things like skew. We can talk about things like measures of center, and we can talk about things like measures of variability as well as outliers. So if I looked at this one, well, remember, everything below Q1, that's 25% of the values. Everything between Q1 and the median is another 25%. Everything between the median and Q3 is another 25%, and everything above Q3 is 25%. That's how it's split up. So I could look at this and I could say, okay, the skew, what do you think? This is the me saying. How do you think it's, do you think it's roughly symmetrical? Do you think it's skewed to the left, to the right, a little bit, a lot? What do you think? Skewed a little bit to the right? To the left, right? Why? Because of these outliers. Like this looks pretty symmetrical. Like we could go down the middle and it looks pretty even on both sides, but this kind of drags it a little bit to the left. And for the measures of center, what would we say? Well, we could just go here and say the median looks like it's about 8.2. What could we say for the variability? We could find the IQR. We could do Q3 minus Q1, which looks like it's about, I don't know, 9.9 minus 6.5. And we could say there are two outliers. Why? Because there's two dots. So just as a little bit of extra practice, how would you say this is skewed, if it is? Yeah, skewed right. So we would say right skewed. And this one, left skewed. So notice with box plots, we really don't use the mean and standard deviation. We use the median and the IQR to describe the distribution. Sometimes you'll be given a box plot and then you may be given all the information below, including the mean and standard deviation. Okay? But it's important to remember that the 5-number summary splits the data up into 4 sections. Everything from the minimum to quartile 1 is 25% of the data. Everything between quartile 1 and the median, sorry, I should say is about. Here it's exactly, but sometimes depending on how many total numbers you have, there might be 3 here, 4 here, 4 here, 3 here. So it's about 25%. About 25% between these two. About 25% between these two, and about 25% from Q3 to the max. Okay? You could be asked a question like that. You could be given the 5-number summary. Like I could give you this. You don't have to write this down. Excuse me. Come on. So I could say 1, 2, 4, 4, 6, 7, 7, 10. Okay. And I could ask you, I could say, what data values represent the bottom 25% of the data? Which data values here represent the bottom 25%? 1 and 2. Because there's 8 numbers, 25% or a quarter is below 1 and 2. Okay. What values represent the middle 50%? 4, 4, 6, 7. You get the idea. Okay. So just to answer these questions from here, from this set of data, what percent of the data is below Q1? 25%. Which means, sorry, what percent of the data is below Q3? 75%. What percent of the data is above Q1? Is above Q1? 75. What percent of the data is above the median? 50%. And what percent of the data is between the IQR, Q1 and Q3? 50. You should be familiar with that and make for a good multiple choice question. The next page shows a box plot of this data, this specific data that we've been working on. We calculated all this stuff using our graphing calculator. We punched in all the values into a list. We did our calculations. We got the minimum. We got Q1. We got the median. We got Q3. We got the maximum and This lesson, we were also able to calculate the outliers. So you are asked to describe the distribution, which means you need at least how many sentences? 4. Okay? And I'm okay if you go point form. So we want shape, center, variability or spread, outliers. Shape. Yeah. The distribution has a right skew or is skewed right. Distribution is skewed right. Center. You can be exact. What measure of center do we actually know? The median. So the median is what? Sorry? Okay, but we want to answer in terms of the question. 34,500. What about the variability or the spread? Which one represents that? Which spread measure goes with the median? The IQR. Okay. And what was it? We calculated it. Units and context of the problem. We calculated it on the first page. It was 7, but because it represents thousands of dollars, we have to say the IQR is $7,000. And outliers? There are 2 outliers. Definitely something you're going to be expected to do this test for sure. I'm going to give you a graph and some numerical information, and I'm going to ask you to describe it. Or I'm going to give you 2 graphs, information with each, and I'm going to ask you to compare them. Okay? But you got to remember, we do it this way. We talked about, I'm sort of revisiting this because we talked about comparing distributions before. Okay? So as an example, we're going back to the tax cuts. Okay? Here are 2 box plots that represent 2 different tax cut plans, A and B. Okay? If we averaged each one, found the mean, they would be exactly the same at $1,260, even though the box plots look very, very different. We're going to look at that in a second. So what if we were asked to compare these 2 distributions? So quantitative distributions, we always use SCIVO. So you got to have at least 4 sentences or 4 bullet points. And I told you this before, use comparative language when you describe. So you could say the median of one is this, which is greater than the median of the other, which is this. The IQR of this is less than the IQR of this, or the IQR of this, which is such and such, is less than the IQR of this, which is another number. And this applies to dot plots, stem plots, histograms, and box plots. You guys have already done some of the stuff with dot plots, stem plots, and histograms. So we want to compare the 2 distributions, Plan A and Plan B. So let's talk about the shape. How would you compare the shape of each 2? How would, Like, first of all, really, you can't say one is greater than the other or one is less than the other. You could say that they're similar or they're different. How would you describe the shape of A? Remember, you got three choices. Skewed to the left, roughly symmetrical, skewed to the right. I would say probably roughly symmetrical. If you said there was a slight skew to the left, I'd give you that too. Either one of those would be correct. But B, sorry, really skewed to the right. So we would say plan A is roughly symmetrical. Whereas plan B is heavily skewed to the right, or heavily skewed right. Center. Well, because we're dealing with box plots, we're dealing with the median. And we can actually get values for the medians of both of these plans. Not perfect, but close. So you got to use the horizontal axis. You got to find the median bar in A. And what would it be about the median? Yeah, that sounds about right. About 1,400. How about plan B? Here, 30? 100 to 200? Somewhere around there? Sure, 100, 200 is good. Okay. So we would say plan A has a median of about, and I'll just even put in 100 to 200. If you put 100, that's fine. Oh, sorry. It's about 1,400, which is greater than the median of plan B. Which is about 100 to 200, or 100, or 200. That's my best. Spread, variability. Well, if we're using the median, what's the variability measure we use? IQR. That means we got to find the ends of the rectangle and subtract them. So this is about Q3 in plan A is about what? 2,500. So the RQR for plan A would be, yeah. So plan A has an IQR of about $500. What's that? What? 502,000. 1,500. which is greater than the IQR of Plan B, sorry, I shouldn't say it's greater yet. I think it's going to be greater. Got to calculate it first. It's a smaller box, so it's going to be. So what would you say that is? 500 minus 50, 100, somewhere around there. So 400 or 450, which is about 400 to 450. I'm running out of space, so I'm going to have to write the outliers up here. Doesn't allow, this is a new program, updated program. It doesn't allow me to extend the page anymore. Not cool. Outliers. You don't have to be specific with outliers. Otherwise, you're going to be writing numbers for a long, long time. So Plan A has no outliers, whereas Plan B has many outliers. Okay. Now relating to tax cuts. Really, we can talk about two types of tax cuts. Broad, which means it affects a large amount of the population, or narrow, which means it affects the small amount of the population. Okay, affects significantly, or significantly, I should say. Okay, so think about, like, would Plan A be a broad tax cut or a narrow tax cut? What do you think? It would be broad. Because if you think about it, 75%, remember this is Q1, so this goes up to, this is 75% of the data has a tax cut of above $500. So a pretty significant amount of the population has a tax cut above 500 bucks. And yet, if you look at Plan B, what percent has a tax cut above 500 bucks? How much does this represent? No, it doesn't. 25%. Okay, I know it looks like more, but remember, Q3, that means 75% is below, 25% is above. So in this plan is a narrow tax cut because most people got a tax cut below 500, and only a few, 25%, got above 500. Okay? So that's how we would answer this question. Is we would say Plan A shows a broad tax cut. Because 75% of households had tax cuts of 500 or more. Plan B shows a narrow tax cut. only 25% of households had tax cuts of 500 or more. And yet, if we found the mean or the average, remember that's different from median, it's exactly the same. The average tax cut was 1,260 bucks. Okay, how can that be? Think of the relationship between the mean and median. And what does that do? If there's a lot of outliers, what does it do to the mean? Actually, sorry, if there's a lot of high outliers, what does it do to the mean? It drags it up, doesn't it? It pulls it up. So like if you look, like here we said this was roughly symmetrical. So the medians here, which if it's roughly symmetrical, the median and the average and the mean would be about the same. So here, the median is about, well, the mean would be a slightly lower because there's a slight skew. So it's about 1260. Here, well, the median is way down here, but because of these outliers, it pulls the mean up, level with this. So both tax cuts have a mean of 1260, but if we look at other numbers, other measures, and a box plot of both, it tells a different story. Because if you just calculated the mean, you would say, well, it doesn't matter which one, the average tax cut is still 1260. But then when you look at this, you say, yeah, but there's a lot of rich people that are bringing the mean up. Okay? Most of the people are actually getting a small tax cut. So this seems a little bit more in favor of wealthy people, where this seems to be a little bit more evenly distributed among wealthy and less wealthy. So just to wrap this up, Plan B has many high outliers. And will therefore pull the mean up. Because remember, the mean is not resistant to a mean similar to Plan A. Which has no outliers, that pulls the mean. The mean and the median are pretty close in Plan B, but the mean and the median, sorry, the mean and the median are close in Plan A, but the mean and the median are really different in Plan B. We saw the median was quite low, but the mean, because of those high outliers, was pulled up. Okay? So the lesson from this is, don't just look at one measure of data. The story could tell much more than that. Okay? Okay, I'm not going to worry about the discussion. If you want to read that, you may do so. It's on Teams.